talking about evaluating algebraic expressions. You're going to see three VICs, V-I-C. Those stands for very important concepts. Those are things that I really want you guys to get because they're obviously very important concepts. VIC number one, evaluate. This means to find the solution. Evaluate does not mean solve. Solving is different. Okay, we are evaluating or finding the solution. VIC number two, use substitution to evaluate expressions. Substitution means replacing one thing with another. So we're going to be replacing variables with numbers. Use substitution to evaluate expressions. VIC number three, follow order of operations when evaluating. This is our PEMDAS. Remember, please excuse my dear Aunt Sally. Always follow order of operations. Even if it doesn't specify, you always must follow the order of operations to evaluate. We're going to do a few examples. Examples, evaluate. Don't forget to use PEMDAS. Example 1, t minus 8 when t equals 18. Notice they give you what they want t to be. They give you the value of t. So all we do is substitute. We plug in 18 for t. So t is now 18, bring down minus 8. 18 minus 8 equals 10. We know that t minus 8 or 18 minus 8 equals 10. Example number 2. 6w plus 9 when w is equal to 3. Again, they give us a value for w. W is 3. So we plug it in or substitute. 6 times 3. 6 times w. Notice I put a parentheses around the 3. Why did I do that? Because 6 times w, you have to imply multiplication. We could have used parentheses, we could have used a dot, we could have used the multiplication symbol, but you have to put something to represent multiplication. If you just wrote 6, 3 like this, it would look like 63. That's not what we want. We want 6 times 3. All right, 6 times 3 plus 9. Order of operations tells us that multiplication comes before addition. 6 times 3 is 18, and 18 plus 9 is 27. So 6w plus 9 evaluated is 27. Next example, number 3. 3z plus 4 minus 2z when z equals 5. I'm giving you that z is 5. So we're going to substitute. We put 5 everywhere we see a z, even if there's more than one. 3 times 5. Again, here I use the multiplication symbol, the dot, as opposed to parentheses, but it still means multiply. Plus 4 minus 2 times 5. Why did I plug in 5? Because that is what z is. Order of operations tells us to multiply before we add or subtract. So 3 times 5 is 15. 2 times 5 is 10. Bring down the plus 4 minus. We're left with addition and subtraction. Remember, we add and subtract from left to right. 15 plus 4 is 19, and 19 minus 10 is 9. Example number 4, p plus parentheses 8p minus 4, when p is 9. Again, here we have parentheses, but we still do it the same way. We substitute. 8 times p, which is 8 times 9. 9 plus 8 times 9 minus 4. PEMDAS tells us to use our parentheses first, or evaluate our parentheses first. 8 times 9 is 72. Bring down everything else. Still inside of our parentheses, 72 minus 4 is 68. Bring down the 9 plus, and 9 plus 68 is 77. When we evaluate this algebraic expression, we get 77. We have two final examples. Number 5, x to the second power x squared minus x over 2 when x is 4. So we're going to plug in 4 for x. 4 squared minus 4 over 2. Don't forget PEMDAS. It tells us to follow our operation order. We have exponents. What does 4 to the second power mean? Not 8. Remember, 4 to the second power is 4 times 4, which is 16, minus 4 over 2. Do we subtract or divide next? Division comes before subtraction. 4 over 2 is 2. So we're left with 16 minus 2, which we know is 14. This expression is evaluated as 14 for x equals 4. Number 6, 6m minus 1 plus 2m when m equals 5. We're going to plug in 5 everywhere we see m. 6, 5 minus 1 plus 2, 5. This would be a mistake. I did not plug in anything between the two numbers. That looks like 65 and 25. So I have to remember the operation that is implied. 6 times m and 2 times m. So I put in multiplication. Use your order of operations. 6 times 5 is 30 minus 1 plus 2 times 5 is 10. Here I have subtraction and addition. Don't forget you do addition and subtraction from left to right. 30 minus 1 is 29, and 29 plus 10 is 39. We evaluated this expression to be 39.